Okay. So YouTube, should I? Okay, I refreshed once. 3 waiting. Okay. Hello, students. Welcome to the live session of Photonic Crystals Fundamentals and Applications. Uh, Feel free to ask any questions if you have. I don't see any participants. Is there anyone? Yes. So can you? I can't. They're waiting. I don't know how they will ask questions. They have to come online. Is it? Oh, okay. Chat. Okay. YouTube chat. Okay. Fine. And in the YouTube, with my name, School of Business is written. That has to be changed. I'm from the Department of Electronics and Electrical Engineering. Okay. Uh-huh. Fine. So let us wait for any questions. Can't see any questions. Okay. Okay, students, you may ask your questions if you have any.
Hello.
Hello.
Yes, sir. Good afternoon.
Good afternoon.
This is
Yes,
Ibrar.
please. Yes, Sikdar.
Yes, yes. Sir, the actually thing, whatever you are teaching now, so that transcript is not available. And in case for final exam and all, if we get some written material, will be helpful because it's
Okay.
very difficult to remember after 2 or 3 months everything, full complete course.
I understand. Okay. Ibrar, we are working on the transcript, but it will take little time to complete all the transcripts. Okay.
Okay,
So
okay.
more or less, if you follow my lectures, so the transcript more or less have the similar kind of things only, right? There is nothing drastically new that will be added on the transcript. So you can carefully follow the lectures, okay? and then that
Okay.
should be enough for exam as well. Okay.
Okay. Okay.
Yeah, we will be working on the transcript. It takes some time. Okay. So
Okay.
we
Okay.
will slowly keep on uploading the transcript. Okay.
Fine. Fine, sir.
Yeah, I'll do it.
And sir, one more thing.
Yeah.
Uh-huh. I was going through all your lectures week wise. Whatever that textbook you have prescribed. In fact, I just got the soft copy of that also.
Yes.
Even I was going through that. The derivation of the master equation, because I don't know whether I missed you or any of your lecture, or probably have covered or not. I'm not remembering the master equation for photonic crystal.
I think it is the steps are described there. So you kindly follow the lecture sequence, and if you have got the book also, no,
Huh.
that photonic crystals molding the flow of light. That is the name of the
Correct.
book. Okay, so
Yes.
there also you can see the derivation. It's not a very
Okay.
difficult one. It's basically from the eigenmode equation you come to that master equation. Yes.
Okay. Okay.
Uh, uh. So actually, that's a very good point you have brought up. So we are closely following that book, photonic crystals molding the flow of light. So instead of waiting for the transcript, if you want to need a reading material, you can actually read that book. Okay. So
Yes.
beside my lecture, you read that book. That will give you the kind of complete understanding.
Okay.
Okay.
I think one of the questions, sir, I think this week's assignment question,
Mhm.
I think second or third question, I didn't understand it. I, in fact, went through the textbook also, but I was unable to follow what exact was the question. It was there in this week's assignment.
That you can do one thing, you can drop an email to me, as I mentioned always on the lecture, no, that you
Huh.
email to me. Okay.
Hmm.
Mentioning your doubt, we will answer back to you if you don't remember
Okay.
the question right now. Okay. That is
Okay.
not a
Okay.
problem. I'm always available over email. Any
Hmm.
queries you can ask, and like within 1 or 2 days you can expect a answer. Okay.
Okay. Okay, sir. Okay. Thank you.
Okay. Thank you, sir.
Thank you, sir.
Hello, any more questions? Yes. Hello. Okay. Just the camera. There is setting of blur background. I'll do that. Is that fine? Okay. Now see, there is no question, so I'm actually doing some other work also parallelly, right? So whenever there is a question, I will answer turning on my mic. So don't worry about it. Yeah. No, 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 no. I intentionally turned it off. I'm working on something. I cannot keep on waiting, right? Looking at the camera for some questions. I'll wait. Ah, I'm there. Don't worry.
Sir, I got one of the question. Can I say it? The question? It is from the second assignment. There was a problem.
Yes, please go ahead.
Yeah. The electric field intensity of a surface with permittivity 4.5 is given by 27 units. What is the field intensity of the surface in glass with a refractive index of 1.5?
Okay.
It was
Is it
it was there
possible?
in the second.
Is it possible for you to type it in the message? It'll be easy for me to see.
Yeah, I'll try once.
Yeah, please do that. You can share a snapshot also, or screenshot. Okay.
I have shared the question in the chat box.
Yeah, I could see that. Yes. So the electric field intensity of a surface with permittivity is given by 27 units. Okay. What is the field intensity? Okay. So it is based on the continuity of electric field across the interface. So if you see the electric field continuity, what will be? Because there are two refractive indices that you can see, right? One is having permittivity of 4.5 and
Yes,
another
yes.
one is having a refractive index of 1.5. So this is a bit tricky question. Refractive index of 1.5 means permittivity of 2.25, square of 1.5, isn't it?
Yes.
Yeah. So now you can think of, I'll not give you the exact answer, you can think of in terms of the normal component of the electric field displacement is now continuous across the interface. So you can use that.
Okay.
So D, the displacement field D is continuous, and D depends on electric field and the permittivity. D equals epsilon E. Understood?
Okay.
Yeah. With that, you can answer this question. Yeah. Good.
Sir, I have shared one more question. Can you please elaborate this? It is in the chat box.
Sure. Chat box, this one, right? At the atomic scale.
Yes.
Okay. At the atomic scale, particles which are very small, like electrons, okay, begin to display dash properties, including interference and non-localization. Right.
Yes, sir.
So what kind of properties? So there are like wave interference is a phenomena that can be only explained by wave optics, isn't it?
Yes.
If you take ray optics will not explain your interference. So the wave kind of properties will actually uh, help that. So when the particles are of very small size, that means atomic scale, they will basically display that sort of property. Okay.
Okay.
It is basically the fundamentals of that difference is there, na? Ray optics, geometric optics, and
Hmm.
electromagnetic optics, wave optics, all those things. So this question is basically to probe the understanding of the boundaries that
Hmm.
when the particle becomes large, you can use ray optics. Okay,
Hmm.
that means the particle is like much larger than the wavelength of light. Okay,
Okay.
and when the particle becomes small and gets very small as compared to the wavelength of light or even comparable, you can go for uh, wave optics to explain all this phenomena, something like interference and non-interference. Okay.
Okay. Okay. Okay. Thank you, sir.
So there is a book of Saleh and Titch. I think that is called Fundamental of Photonics. Okay. The book
Fundamentals
is
of
by,
photonics.
yeah, Fundamental of Photonics. Let me look for the name. Just a second. Fundamentals
Yeah.
of Photonics. Saleh. Yeah, Fundamentals of Photonics. Saleh and Titch. So if you take that book from
Huh.
library or from say any online source, there in the very beginning, okay, there are a couple of chapters that basically tells you about this details of which boundary you should follow, like ray optics is valid for which case, wave optics for which case, and so on. Okay.
Okay. Okay. Okay.
Uh, so in the context of photonic crystal, this becomes important because in the photonic crystal is somewhere, the structure and the periodicity becomes of the order of the wavelength of light, isn't it?
Correct. Huh. Huh.
It is not strictly nanophotonics where the gap or the nanoparticle spacing are in the nanoscale. Here, if you see the structure details, the periodicity is of the order of, say, the wavelength. So the optical domain here, okay, is
Hmm.
mainly that it is not sub-wavelength, it is comparable to wavelength. So you have all these different effects coming up.
Okay. 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 Thank you so much, sir. Thank you.
Okay, no worries.
Sir, if you are done, can we leave the meeting?
Sure, if you have not no more questions, you may leave the meeting. And good luck.
Oh,
Good luck with the
okay.
course. Okay?
Thank you. Thank you so much, sir. Yeah,
Okay.
sure.
Thank you. Bye-bye. So as there are no more questions, can we close the live session? Yeah. Okay. Thank you then. Huh? Bye. Bye. I'm leaving. Huh? Bye.